All right, let's go over the answers to the homework. Let me just point out that there's not always a lot of work to be shown on these problems. So if you feel like, Mr. Davis likes me to show my work and I'm not really showing a lot, that's okay on these. Okay, this is a basic skill. If you were one of those people who multiplied two-digit numbers together in your head and didn't write that down on a piece of paper for a problem, I'm okay with that. Okay, skills-based things like that, I'm fine with you not showing your work. Conceptual things, I want you to show your work, if that makes sense. So, for number 1, x is 9 square roots of 3 and y is 9. For number 2, x is 8 square roots of 3 and y is 4 square roots of 3. Number 3, pardon me, x is 24 square roots of 3 and y is 48. Number 4, x is 28 square roots of 3 over 3 and y is 14 square roots of 3 over 3. Number 5, x is 21 square roots of 3 over 2, and y is 21 over 2, or 10.5. I'd be happy with either of those. Number 6 is 16 square roots of 3 for x, and 32 for y. Number 7, x is 15 over 2, and y is 15 square roots of 3 over 2. Now on that one, for x, I'd be happy if you put 7.5 or 7.5. The reason I usually don't is because when I do the additional calculation, we try not to mix decimals with square roots. So for y, although technically correct, 7.5 square roots of 3 is kind of a non-standard way of writing it. Okay? So then number 8, x is 6 square roots of 3 and y is 3 square roots of 3. Number 9, x is 21 square roots of 3 and y is 42. Number 10, x is 13 square roots of 3 over 2 and y is 39 over 2. Number 11, x is 27 and y is 18 square roots of 3. Number 12, x is 5 and y is 10. Are there any questions on that side? Yes, ma'am.
Number 10, please.
10? Okay. So we've got the hypotenuse, so we've got to find the short leg first. Short leg has to be the first thing you find if you don't already have it. And what are we going to do to the hypotenuse to find the short leg? Yeah, so I would just leave it 13 square roots of 3 over 2. And then what do we do to that to find the long leg? Right, and the way I remember that, honestly, is that if you're multiplying, yeah, as long as the number is bigger than 1, but that's a whole nother story. But yeah, I feel like multiplying typically makes things bigger, so I need to multiply. So we'll multiply by the square root of 3 over 1. So that's 13 times the square root of 3 times the square root of 3 is 3. So that's 39 over 2. Okay? Was it you didn't?
I just did 13. I did like the equation right, and then I did 13 over 2. I just didn't like that.
Oh, you did it like these were dividing instead of multiplying. Gotcha. That's an easy mistake to make. Anything else on the first page? Okay, page 2. Number 13, x is 21 square roots of 2 and y is 14 square roots of 6. 14, x is 4 square roots of 5 and y is 4 square roots of 15. Number 15, x is 5 square roots of 5 and y is 10 square roots of 5. Number 16, x is 3 square roots of 6 and y is 6 square roots of 6. 17, they're both 23 square roots of 2 over 2. Number 18, they're both 7 square roots of 2. Number 19, they're both 7 square roots of 10 over 2. Number 20, x is 8 square roots of 6 and y is 8 square roots of 3. Number 21, x is 11 square roots of 2 and y is 22. 22, x is 8 square roots of 3 and y is 4 square roots of 6. Number 23, they're both 6 square roots of 14. Number 24, they're both 10 square roots of 3. Number 25, x is 15 square roots of 2 and y is 15. 26, they're both 7. And 27, the problem to see if you were paying attention or not, is 2 square roots of 33. Questions on the back? Yes, Savannah?
Number 20.
Number 20, all right. Okay, so since this is a 45, 45, 90 triangle, I know that the legs are the same. So I know that 8 square roots of 3 is going to be the length for y also. Okay, and then what do I do to a leg to get the hypotenuse in a 45, 45, 90? Not by 2, but by the square root of 2.
Oh, okay.
In a 30, 60, 90, to get the hypotenuse, we multiply the short leg times 2.
So it would be x is 8 square root of 6.
Exactly right.
Okay.
I think that's the hardest thing is to remember, well, wait a minute, which time is it 2 and which time is it the square root of 2? And for me personally, I always go back to, if you start with an equilateral triangle and cut it in half, whatever this was, this is half of that. I'm like, oh, so in a 30, 60, 90 triangle, the hypotenuse is twice the short leg. That helps me personally. I don't know if that helps you or not, but that's how I remember it. It's like if I ever get stuck, I go back to 30, 60, 90 triangle and split it in half. Okay? All right, any other questions? The majority of our heavy question askers are not here today. Okay. Then if you would, please go and put that away, and I'll give you today's notes. Pretty short notes today. It's like, wait, it's one piece of paper and there's nothing on the back. Score. If I can get these two to come apart. It's on paper, so it's not all that. Sorry. I know hard means difficult. No, I don't think so. I think most of you.
Over our lesson on Monday.
What was our lesson on Monday?
Is it over like multiplying and dividing?
Yeah, it could be multiplying and dividing. So any kind of simplifying of square roots, including multiplying and dividing, and Pythagorean theorem. Are you a little iffy on multiplying and dividing still?
Well, it's, yeah. The Pythagorean theorem is easy for me. It's just the multiplying and dividing.
Okay. Well, we'll get to practice that a little bit on today's notes.
Okay.
Not a ton, but a little bit. So here, if a diagonal is drawn in a square, you get two congruent 45, 45, 90 triangles. Now, I just have made a claim, and anytime somebody makes a claim, you should carefully consider whether that claim is really true or not. I don't care if it's a teacher, preacher, whatever. Okay? You should go, wow, I need to test this. That's actually scriptural, but we'll get into that another time. So, how do I know that this is going to be 45, 45, 90? Well, if it's a square, what do we know about all the sides? They're all congruent. So when I draw in this diagonal, I create two triangles that I know for sure are isosceles, right? And what else do we know about a square?
Equal angles.
Yeah, and specifically, how big are the angles?
90 degrees.
They're all 90-degree angles. So I've got an isosceles right triangle. So it's got to be 45, 45, 90. And since, I could do it by side angle side, this triangle is congruent to this triangle. So again, anytime someone makes a claim about something, It's not that you have to be, distrustful of people, but when people make a claim, you should check the claim. Okay? All right. Sorry, that's kind of the mathematician's theme. It's like someone claims something, you're like, well, prove it. Okay? So here, if we're trying to find the length of x, I've got a 45, 45, 90 triangle, right? So what do I do to the leg to find the length of the hypotenuse? Exactly. So x is just going to be 15 times the square root of 2. Okay, let's reverse the process. So let's draw another little square over here. And we'll draw in a diagonal line connecting these two vertices. Let's say we know it's a square to start with, and that all 4 of these sides are congruent, and we know that this side is, 28. And we want to find the length of this side. Sorry, we know the diagonal is 28. I said side. We know the diagonal is 28. We want to find the side. Well, if this is an isosceles right triangle, it's a 45, 45, 90 triangle. How do I get from the hypotenuse to the leg? Divide by the square root of 2. Exactly right. I can't just cancel here, although I hate using the word cancel. It's really divide out, but that's another story. Because one is a whole number and the other one is a square root. So we're going to have to rationalize the denominator. How are we going to rationalize the denominator?
Multiply by the square root of 2 over the square root of 2.
Exactly right, and well said. You multiply by the square root of 2 over the square root of 2. So that'll be 28 square roots of 2 over 2 is 14 square roots of 2. Everybody good on that? Okay. So, next example. If a diagonal is drawn in a rectangle, 2 congruent right triangles are formed. Well, I don't think anybody has any trouble verifying that in their head. They're like, yeah, that's got to be, those 2 triangles have to be congruent to each other. And here, if we want to find the length of the diagonal, what is it that we need to do?
Multiply by the square root of 3. Multiply the short leg by 2.
So what kind of a triangle are you assuming that this is then?
30, 60, 90 triangle.
Yeah, so you've made it, again, back to the claim. You have claimed that this is 30, 60, 90 triangle. Do we know that? In fact, I'll go a step further. We know it's not. Now, how do I know that it's not a 30, 60, 90 triangle? Well, if it was a 30, 60, 90 triangle, if the short leg was 24, what would the long leg have to be? It'd have to be 24 square roots of 3, and it's not. Okay? We're just going to use the Pythagorean theorem, exactly. And I will say, typically, on a problem like this, if the numbers are big, you can usually, not always, but usually, divide out something like we've been doing, find a common factor. Here, unfortunately, there is a common factor. What is it? I overlooked it. What's the common factor? 3. So this is 3 times 8, and this is 3 times 15. So this is going to be 3 times something. Oh, and that's even better. Do you recognize that? 8, 15, 17. That's 3 times 17 is 51. I didn't have to do any ugly squaring. So anytime you see largish numbers in the Pythagorean theorem, look to see if they have a common factor. If I wrote it, they almost always do. Okay? And if not, now you're having to square 24, which isn't all that bad, and square 45, which, because I taught you the trick for that, is not hard. Do you remember the trick? For 45 squared, you don't have to know this, but it's kind of nice to know. Right? And you're going to take this number, 4 times 5, this number times that number plus 1, it's 2025. The ugly part of this one would have been after you subtracted, because 24 squared is not all that bad. It's 576. It happens to be one of the ones that I know. I don't know a lot of them. But then after you subtract, simplifying, ugh, it's just ugly. Okay? All right, let's move on. Last example, and actually I probably will do another one. So if an altitude is drawn in an equilateral triangle, 2 congruent 30, 60, 90 triangles are formed. Okay, well, how do I know it's a 30, 60, 90 triangle? And what are all the angles in an equilateral triangle?
60.
They're all 60, exactly right. So these were 60. And this cuts that in half, so each of these is 30. So it is 30, 60, 90 triangle. The altitude is sometimes called the height, like when you're doing half base times height to find the area of a triangle. If you want to get technical about it, the altitude is this line, and the height is the length of that line. I can't get a whole lot of worked up about how important it is to call one the height and one the altitude. They're pretty much used interchangeably. So this is going to be which side of the 30, 60, 90 triangle? The long leg. So what do we have to find first?
Short leg.
By doing what?
Dividing by the square root of 3.
Exactly right. Dividing by the square root of 3. So we're going to take 12 divided by the square root of 3. I can't reduce that because one's a whole number and one's not, so I will rationalize it. And we get 12 square roots of 3 over 3 is 4 square roots of 3. Which means that x is 8 square roots of 3. I will say eventually we'll do this as a word problem, and I'll say something like this. In an equilateral if an equilateral triangle has an altitude of length 12, what is the length of the side of the triangle? And I swear to you, it happens just about every year that someone at some point will go, well, which side of the triangle do I want? I'm like, it's an equilateral triangle. Which means what? They're all the same. What they're thinking is, which side of the 30, 60, 90 triangle do you want me to tell you? I'm like, I want you to tell me a side of the equilateral triangle, which is 8 square roots of 3. Okay? If we were going the other way, let's just do a quick example of that because that takes 0 time just about. It takes longer to draw it than it's going to take to do it. So if we take an equilateral triangle and drop in an altitude, and let's say that we want to know, well, what is the height? And we know that each side is 17. So what side of that 30, 60, 90 triangle do we have?
Hypotenuse.
Right? So we have to find what next?
Short leg.
The short leg. We do that by doing what?
Dividing by 2.
Dividing by 2, which, frankly, you don't have to know that really, do you?
7.
Yeah, you know that this is going to be half of this side down here on bottom, right? And then to find the altitude, what do I need to do to the 17 over 2?
Multiply by the square root of 3.
Right. So that's 17 over 2 times the square root of 3 over 1, 17 square roots of 3 over 2. Any questions about that? Okay. Then I'm going to give you your worksheet, and then I'll give you your quiz.